Okay, so in this video, we are going to talk about indirect and direct variation, or being proportional and inversely proportional. It can be worded either way. So let's say you have a problem that says this, a word problem. This is a really easy way to set up a lot of these problems. Once you get past the vocabulary and you know how to set these up, they're much easier to work than a lot of other types of story problems. Okay, so let's say you have something like this. The distance sound travels varies directly as the time it travels. So we're going to set up all of our variation equations in the form of y equals k times x, or y equals k divided by x. So if I tell you that the distance that sound travels varies directly as the time, so these are our formulas, then this is the formula that we're going to use for this particular equation. The distance is proportional to the time. Then it's going to give us some numbers. It says if sound travels 1,340 meters, so 1,340 meters, and then k is our constant, in 4 seconds, we're going to plug 4 in for time, then we're going to divide and find our k value. You're always going to find your k value, because after we find our k value, the problem is going to ask us to find the distance that sound will travel in 5 seconds. So I know you can't read the problem, so let me read it again, the whole problem, okay? The distance sound travels varies directly as the time it travels. If sound travels 1,340 meters in 4 seconds, find the distance sound will travel in 5 seconds. So we put our numbers into our equation, and we're going to find k. So we're going to divide both sides by 4, and that gives us that k is equal to 335. So that means for this particular problem, the distance is 335t. And then the question was, find the distance that it will travel in 5 seconds. So we're just going to put 5 in for time. And then 335 times 5 is 1,675. And our original unit was in meters, so this is going to be in meters. So, whoops, sorry, can't see that. So that is how you would work that problem, okay? If you have an inverse variation, okay, then you're going to set it up using division. So I'm going to read you the whole problem, and then I'll work it, okay? Boyle's law states that the volume V of a sample of gas varies inversely as the pressure P. The volume of a gas is 75 milliliters when the pressure is 1.5 atmospheres. Find the volume of the gas when the pressure is increased to 2.5 atmospheres. So basically, we're told that the volume is inversely proportional to the pressure. And then we're given that when the volume is 75 milliliters, the pressure is 1.5 atmospheres. And then we want to know what the volume is when it increases to 2.5 atmospheres. So we're going to take the numbers that go together in the same situation and plug them in and find our k value. So 75 is equal to k divided by 1.5. So to solve for k, we're going to multiply both sides by 1.5, and that gives us that k is equal to 112.5. So for our problem here, our volume is 112.5 divided by p. Okay, so this is an important equation for this problem. Over in the other one, the other example I did, this was the equation that we got after we found our k value. Now we can take the number that they gave us and find the missing value. Well, that's our atmosphere, so that's our pressure, so our volume is equal to 112.5 divided by 2.5, and when you divide that out, you get 45 milliliters. The common sense way of looking at these problems is that when you have a direct proportion, if you make one larger, you're going to also make the other one larger. With an inverse proportion, if you make one of them larger, then you're going to make the other one smaller. So this one, the pressure increased, so that means the volume is going to decrease. That's what it means to be inversely proportional, okay? All right, you can make these more complicated. So let's do something with a couple of more numbers in it. The cost of insulating a ceiling, and again, I'm going to read the whole problem and then I'll work it, okay? The cost of insulating the ceiling of a house varies jointly, so it just means we're going to have more than one variable, as the thickness of the insulation and the area of the ceiling. Then it's going to give us the numbers. It cost $1,750 to insulate a 2,100 square foot ceiling when it is 4 inches thick. We want to know the cost when we have a 2,400 square foot ceiling and we make it 6 inches thick. Okay, so we go back to the statement that it gave us at the beginning. The cost is jointly, or varies jointly, as the area of the ceiling and the thickness. So you can use whatever letters you want to, A for area, T for thickness, C for cost, okay? So now we're going to plug our numbers in so we can find our K value. So 1750 is equal to K times 2,100 times 4. Now it might bother you that this is feet squared and this is inches. You don't need to worry about them being in the same unit. What you have to worry about is that the A is always with the same unit. So if this is in square feet, this has to be in square feet. If this is in inches, this has to be in inches. If this is in inches and this is in feet, then you've got to convert them, okay? They have to be, each variable has to always be in the same unit, but the different variables don't have to be. Okay, so now we're going to take 1750 divided by 2,104 to get our K value, and K comes out then, if we leave it as a fraction, as 5/24. So that means our formula that we're going to use is C equals 5/24 times area times thickness. And again, that's the main thing that we're looking for. We found our formula now. Now we can plug our numbers in. So our cost is equal to 5/24 times 2,400 times 6. And when you put that in your calculator, you will get that is $3,000. Okay, so hopefully that helps clear up some direct and inverse proportion problems. If you're in my class, this will help you to be able to do your assignment. So good luck.